on the channel for other users. Again, my name is Uma. I'm co-founder and maintainer of Litmus project. Along with me, we have a few Litmus core maintainers. One of them is Karthik. He is with us, and we both are going to present some topics here. Here is the agenda for the session today. First, let's get to know each other. If there are any new users joining, we have Laura joining us. Thank you, Laura. If you don't mind, if you want to introduce yourself, that would be good.
Yeah, why not? Can you hear me?
Yes, we can.
Very nice. Yeah, well, I live in Germany and work here, and I still study computer science in my 5th semester now, bachelor degree. And yeah, I do a so-called dual study program, which is I study and work at the same time, or in turns, and yeah, get a lot of practice.
Awesome. And thank you for using Litmus and reporting some issues, and also doing some contributions. Great to have you on the community. And primarily for users like you, we want to have this community call like a more generic open source project where community can drive the roadmap, as well as we can all get together and then discuss the topics. So we are planning to have this monthly, third Wednesday of every month at the same time. Today, we don't have any new topics that were requested by the external community. So we put together some agenda. But this agenda is really driven by the community itself. The meeting notes is going to be maintained in open. So feel free to edit these notes and add agenda for the next meeting. And then this meeting is being recorded and we'll be posting it on the channel and also somewhere on YouTube on our community channel. So today what we're going to do is I'll probably introduce Litmus as this session is being recorded. It may be useful for other community members who are trying to get started on Litmus to know what Litmus is. And then Karthik is going to talk about the recent release, which we pushed out last week. For those of you who are new, we have releases every month. That is 15th. We try to get a release out. So 0.9 went out and 1.0 is coming up on 15th of January. And also as part of this community call, we would like to say thank you and give a good shout out to the contributors that have been helpful in growing the community in the last 1 month. And then we touch upon what's coming, what are we working on for this upcoming release. Then before we wind up, we cover a quick demo of how any developer can get started in contributing to a new chaos experiment. Then we also do a good number of meetups locally in Bangalore, but we also encourage community to do the meetups elsewhere as well, anywhere on the globe. So we talk about what's coming up here, and also this serves as a good opportunity to start meetups on the other places. We do help community members to spread the word, so we'll talk about that. So with that, let me talk a little bit about Litmus itself. So Litmus really started as a chaos engineering project or a framework for another open source project called OpenEBS. where OpenEBS is written as a Kubernetes native application, and we were looking for doing failure testing and do some real chaos engineering for that project. We ended up writing our own and then realized there is an opportunity for Litmus to be used by others who are on Kubernetes. So we open sourced it, and now it has become a full-fledged project for Kubernetes chaos engineering. So let me talk about. So in the cloud native environment, our code is really 1%, even though you write thousands of lines of code. There's a lot of dynamism below your code, including Kubernetes and other large applications like Node.js or Linux itself. So your code is really 1%, and microservices-based architecture remains really dynamic. So how do you really make sure that your deployments and infrastructures are resilient? So the answer in general is chaos engineering. So that's typically the starting point. And here I do not really want to talk too much about CI pipelines, how Kubernetes CI pipelines can use Litmus. Well, they can use Litmus using the chaos charts. But let's really talk about how you can use it in staging and production, for example. So Kubernetes being very widely adopted, the developers have standard APIs like pod or service, stateful set deployment, and custom resources. And that's for development. And for chaos testing, you do not have any APIs before Litmus was born. And with Litmus, you have 3 primary CRDs. It's Chaos Engine, the first one, and the second one is Chaos Experiment and Chaos Results. Using these 3 CRDs, any developer can start practicing chaos engineering. Chaos engineering, during the practice, the results come out, and you can use those CRs of chaos result to do your analysis and see whether your application or infrastructure is resilient or not. So this is basically the crux of Kubernetes chaos engineering using Litmus. Use the CRs and tune the experiments and run them in a very Kubernetes native way, and then observe the results. So let's see how any Kubernetes developer can do the regular development. So as part of the development, you create a pod, and then using the declarative YAML. Similarly, to create any other resources, use declarative YAMLs like persistent volume or any other objects like a service. And then you develop your application and test it. To do chaos testing, you can inject the chaos in a very similar way using another CRs or CRDs like Chaos Engine, and then run experiments. So that's really how you can use Litmus. It is really an extension of your regular way of doing development or operations on Kubernetes. And that's primarily the main advantage of using Litmus for chaos engineering on Kubernetes compared to any other tool or project out there. So with that, let me talk a little bit about what Litmus has come to so far. We are still, I think, there are reasonable contributions from the community out there. One of the primary contributors are OpenEBS developers who are using Litmus for their testing. But we do have a good number of followers on GitHub with about close to 500 stars now. And there's a blog that we posted on CNCF, which gives a decent overview of how Litmus can be used to do practice chaos engineering. So do take a look at it. And the entire project is under Apache 2 license. Everything is in open source. So this is the website. And if you go a little bit into the architecture, you have applications that use Litmus for injecting chaos. The chaos can be of any type. We call them as chaos experiments. And then this chaos really is injected using some plugins. So Litmus is a library that has the core logic for injecting chaos, but I can use other chaos tools also in Litmus infrastructure, like Pumbaa or Powerful Seal. You can use Litmus as an infrastructure, if not as a core library itself. So that's another advantage for other chaos tools to use Litmus to practice chaos engineering. So Chaos Hub is another innovation I think we have introduced. It's very similar to Helm charts, where everyone packs their binaries into a chart, and there is a generic way of installing them and upgrading them. So very similar chaos experiments are grouped into a hub called Chaos Hub, and developers can push them, and ops people can use them. So it's a good combination of development and usage, and we are hoping more developers will come and push their chaos experiments into the hub, so their application users can do chaos testing in staging or in production. So how Litmus works, how to use anybody is you will have readily developed experiments on the hub, and you install Litmus using a simple YAML operator. And then that installs operator as well as chaos libraries. Then you pull in the charts, and the charts are installed onto your Kubernetes cluster. And then you inject chaos by introducing a new CR onto your Kubernetes cluster. Once the CR, Chaos Engine CR, is created, chaos is injected through a new chaos container, or we call it as a chaos runner. And once chaos is done, a result CR gets created, which you can use. So that's as simple as it gets. And how to give feedback is we're looking for community to give more thoughts on what Litmus can do for them, or if there are some gaps. We created an issue called 1001, and we are planning to keep it open. Please feel free to enter your comments on this issue. That's a quick introduction to Litmus. I would like to stop here for a while and see if anyone has any comments on Litmus, or do we need to copy any, talk about any other agenda items in this call. All right. With that, we'll move on to the next agenda item, where we talk about the recent release. Karthik, you want to take it away? I'll just stop my screen share.
Sure. Is my screen visible?
Yes.
Okay. Thanks, Uma, for that introduction about Litmus. We'll quickly talk about the 0.9 release, which we did last week. I have a blog that's coming up on the MayaData blog that talks about it. I'll probably use that as reference to just talk through what were the items that we sort of added into the release. So the agenda of the release or the charter was mainly about stabilizing the infrastructure that we have and improving the experiments, along with adding more docs for easier self-adoption. These were the three main items that we thought of when we went ahead and planned the 0.9 release. One of the things that really motivated us was the feedback that we received from the KubeCon that concluded last month in the third week of November. And we did receive a considerable amount of feedback. There was some approval about the approach that we've taken. So that was great validation about the approach using the CRTs for defining the chaos. And we also talked about the need for better application specific checks. So we did introduce Kafka experiments in the previous release, and we also added improved health checks for that. So I'll just probably take you through a quick summary of what we've done. So one of the items was improvement to the generic experiment suite. So a lot of people who are beginning to adopt chaos engineering as a practice in their organizations seemed to prefer the generic experiment suite as a good way to get started. And the pod delete experiment and the container kill experiments, along with the network chaos, have been probably the more popular ones compared to the infrastructure experiments that we have for the disk fill and the disk loss, probably because of a lower blast radius. And we got a few requests for enhancing the capability of the pod delete experiment, wherein we can do group kills. So there are various use cases where this experiment is being used during performance run benchmark runs. And people are not only checking resiliency of their applications with this experiment, but also are trying to figure out how the system behaves in terms of latency and performance dips and spikes as these events occur. So that's one of the features that we introduced. So there is an env variable on the experiment called as kill count, where you can specify the number of pods that you can delete for a particular deployment. That is the application that the app replicas that share the same label in a given namespace. So the next improvement was around the network chaos experiments. So yeah, once again, thanks to Laura for actually pitching in with testing all the generic experiments that we just spoke about and suggesting the improvements and testing the improvements. One of the challenges that we had with respect to the network experiments was we needed the TC traffic shaper binary available on the application pods for us to be able to create the traffic rules on those pods, on those containers. But we did see that a majority of the applications do not include the TC binary in the base image, so which made the experiment not interoperable with a large set of base images. So there was a workaround wherein we use IP route containers which run with netadmin capabilities to reuse the network stack of the target container and inject the traffic rules as desired. But to be able to use this, we needed to upgrade the Pumbaa release, which has undergone some drastic changes with respect to the way Pumbaa can be operated. So there were some experiment enhancements which were made to facilitate that. Now, with the changes that we've made, you can execute the network chaos experiments on all base images, irrespective of whether they do support or it already has the TC binary available in it or no. And now we also discovered that the network chaos experiments were inherently not interoperable with Minikube. So there are a lot of people who use Minikube for the initial beginner mode or for the trial mode of different projects, Kubernetes projects. And Litmus network experiments weren't working with Minikube because of a lack of the NetM kernel module. And now that has been added by a PR from Laura, and 1.6.0 onwards with Minikube, the NetM support is available, and these experiments are interoperable with that as well. So that was one of the changes, that significant changes that has gone in. We are now supporting the ability to inject config information into the experiment via config maps and secrets. This comes as a handy feature for OpenE-based experiments where application info is injected into the experiment in order to facilitate data consistency checks during the course of the experiment, and also for platform specific experiments or infra-chaos experiments where in all probability you would need the platform information or the service account keys or the access tokens that need to be passed to the experiments in order to establish out-of-band connectivity to the platform. Let's say you would want to do a G-Cloud or AWS CLI command on top of your from your Litmus container into the platform where it resides. Then this information needs to be passed, and it's now possible by the support that we've added, where you can mount secret and config map volumes into the experiment. So that's one of the changes that has gone in. Apart from the generic experiment suite, we made some small enhancements to the Kafka experiments as well. So as part of the best practices that we plan to adopt for all application chaos going forward, we're trying to add application-specific health checks to be used as the pre and post chaos validation steps in the experiment. And for Kafka, we are now trying to use the Zookeeper to identify the number of available brokers before we start the experiment and after the chaos. So that's one of the changes that has gone in. Thanks to Bhaumik, one of our contributors, for having reviewed the Kafka experiments and provided more feedback to enable us to add these changes. And we've also introduced the network chaos experiments for Kafka. Right now we support the Docker runtime, and there are plans to support other runtimes as well. The Pumbaa image, the lib image environment variable inside the network chaos experiments will help us define the support for different other runtimes as well. So that was about the application chaos experiments. And there was a significant change thanks to Rahul, where we are trying to introduce a new chaos runner, which has been rewritten in Go. The current one has been written in Ansible. So we identified that the chaos runner is a core infrastructure piece of Litmus, and it needs to be more scalable, more performant, and there are a lot of features that we would like to build on top of this in order to support improved observability while executing the experiments, such as supporting an audit trail, and to also have better control of the chaos execution itself, such as being able to abort experiments, perform recovery steps, etc. So we've laid the foundation for all those future enhancements by introducing this new chaos runner. It's currently in alpha stage, and you can try it out by making the following change in the chaos engine spec. You need to specify the runner parameters, the runner properties, where the type is Go and the image is chaos executor with tag CI. So this is one of the significant changes that has gone in this 0.9 release. And thank you, Rahul, once again for these changes. And the other probably most significant change that has gone in is adding more docs. We received quite a lot of feedback around how the docs needs to be structured and what should be present in it. And while this is work in progress, we've taken some first steps towards improving the documentation to aid self-adoption of the Litmus project. So we now have, let me probably just bring up the docs website as we speak. we now have a new section for experiments where individual experiment specific logs are available. This is the format that we're trying to follow, where we're talking about what is the prerequisite for a given experiment, how it functions, and what are the tunables that are to be provided as part of the experiment, which of them are mandatory and which of them are optional, and a sample chaos engine that can be used to run this. As always, the docs is something that we need to continuously improve upon. Probably in the subsequent releases, we will add a demo video to accompany the individual experiments to sort of get people started quickly. So please feel free to take a look at these talks and give your feedback and raise issues and PRs. So that's about the docs, and yeah, so that was about the release items for 0.9. Thanks also to Jayesh, who came in and gave us feedback about what to improve on the experiments. So the conclusion is that we're trying to get closer to creating a critical mass of experiments that can help you perform end-to-end chaos engineering. So upcoming release is going to feature resource chaos experiments for the app instead of having it at an infra level to reduce the blast radius and probably help people adopt quicker. Then we're also trying to add schema level validation for the LitmusChaos CRDs. There has been a considerable amount of code that we are writing in the runner right now to validate whether the spec is valid, but we will try to leverage the OpenAPI specification to do that at the time you apply the CRs itself. And we're also trying to make the experiments themselves more robust by adding the E2E coverage for that via GitLab deploy pipelines. And we will continue to add more experiments and improve the quality of the new chaos runner, and probably change that to the default chaos runner in the subsequent release. Yeah, so that's about a quick recap. Are there any questions about some of the changes that I just spoke about, or any of the changes that we plan to bring up? Anything that you would like to see in the forthcoming release? Okay. Yeah, so please feel free to post questions on the Zoom chat as well, as in how you get them. That's about the release update. Uma, would you like to
Sure.
Contributions?
Thank you, Karthik. Yeah, so let me just share my screen back. So I think the next thing on the agenda is really talking about the contributions that were received from the community. I think we've covered it, most of them. Thank you, Lara, Jayesh, Haumik, for doc updates as well as Kafka experiment review, and in general chaos engineering infrastructure reviews that were very helpful. This is how the community grows. So we would want to continue your contributions, and also hopefully we'll get new contributors for the next month's call. And we also moved from a release tracker where we used to manage the planning of the releases using an Excel sheet to a more accepted concept of tracking the projects through GitHub issues. So we do have, if you go to all the issues, there are multiple repositories in LitmusChaos organization, but the issues are usually filed, except for the docs, And it is okay to file the documentation issues also in Litmus repo, which is a primary repository of the organization. So the issues are filed, and then we define milestone every month. And you could see there is 1.1 also, which is coming around February, but the current milestone is 15th of January. It happens to be 1.0, so you don't need to really put a lot of meaning into the 1.0, though there are multiple users who are using Litmus for their regular chaos engineering practice. We believe it is reasonably stable and feature complete for you to use for your regular chaos engineering practices. But if you want to really track the project, this is the best way to track. Go to the milestone. The current milestone is 1.0, and you could see that there are 17 issues, which could be either bugs or enhancements. There are multiple labels that are created to help you understand what kind of an issue this is. And some of the primary enhancements that the team is doing is there are some new charts in terms of writing a new chart for DNS itself. And we are moving the core runner, chaos runner from Ansible based to Go based. It will help generate Kubernetes based events, and you can correlate the chaos across multiple components and multiple resources. So that is a fairly significant effort that's been going on for a couple of months now, I would say, and that's being targeted for this upcoming release. So with this, you would see events being generated, at least the facility to generate events. Thank you, Rahul, for working on it. And then remaining ones are primarily various different chaos experiments and chaos charts that are coming up. We're also encouraging the community to specify the list of experiments that you would want or details of an experiment. For example, in this release, we want to collect more details of what chaos testing can be done for Elasticsearch. It need not be implemented in this release itself, but we will seek Elasticsearch community to comment on this issue. So that would be an approach, and that kind of contribution also is very valuable and welcome, because we need to know what experiments that will be valuable for a given application. So that's kind of a quick summary of what we're working on, and we follow agile practices wherein, if there is a new feature request that comes in from the community or a user, that could make it to the release, and we could deprioritize something else. If there is more time, we would pull in more into this release. So feel free to comment on this process also on the Litmus channel if you want something to be done in a different way. Any questions on the release or process? This is a community-driven project, so we would want to hear from community. All right. So before I turn over to Karthik for a quick developer workflow review, I would want to talk a little bit about chaos engineering meetups. We sponsor and help you run in the world. We support you in terms of listing them on our GitHub or in our channels or on the website. and also we could tweet about them. And also we could help with some swag, stickers, and some t-shirts. If you give enough time before the meetup, we could actually send them over. So feel free to spread the word, and also plan to run some chaos engineering meetups in your local area. That is very much welcome. With that, Karthik, do you want to take it over
Yeah,
and run the developer workflow? Yeah. Okay.
sure.
Thank you.
Okay, is my screen visible?
Yes, good.
Okay. So this session is basically about how, as a LitmusChaos developer, you can create new experiments. We've had contributors modifying the Ansible-based experiment Litmus books already. So we do have some expertise in the room. I'll probably go through how you can actually kickstart writing a new experiment. So we wanted to make it easy for the developers to basically get the list of artifacts associated with the chaos experiments. So as you all are aware, there are different components that sort of contribute to the ultimate chaos experiment. So probably just take you through a README of the developer guide. You can find it here in LitmusChaos/Litmus contribute developer guide. So the main components are as follows. So there is the actual experiment business logic that you're going to write. It's also sometimes referred to as the Litmus book in the Litmus language. And it can be an Ansible playbook, or it could be written in any other language, as long as we are basically working with the chaos CRD interfaces. So this process is basically constructing, for the sake of this particular demonstration, let us assume that the experiment is being written in Ansible. So it's going to be about writing the playbook and reusing existing chaos lib. And in cases where the chaos lib is not available, it's about creating a new chaos lib, mostly in a generic manner, so that other experiments can reuse that. And the another artifact associated with the LitmusChaos/Litmus repo, apart from the actual Litmus book, is the Kubernetes job that can run this playbook. This is mostly for test purposes. Before you actually go ahead and create the experiment custom resource. This is what we see in the LitmusChaos/chaos charts repo, where the experiment CR is basically a condensed form of the job, containing details about the chaos experiment parameters. Some of them are default values, and some of them are values that you will have to provide on an instance to instance basis. And there is an experiment chart service version. I'll probably just take you through the chart hub. So the chart service version is, okay, that's a long link. So the chart service version is basically consisting of the data that you're going to see here in the side panels and in the descriptions, and about what all experiment it contains. The canonical source for the chart service version, as well as the experiment CRs, is actually in chaos charts. And they're all placed under or categorized under different groups. Generic is for general Kubernetes experiments. So each experiment is typically going to contain the experiment specific chart version YAML, which has all the metadata that you would visualize on the hub. And you also have the experiment CR itself, which carries details about what are the permissions necessary to run that experiment, and also what are the tunables, some default values and some instance specific information you might have to provide as part of the chaos engine, where the experiment is included as as one of the parameters. So as you can see, there are quite a few artifacts that are needed to actually create a functional experiment. And the reason why we've done this is to basically keep the architecture decentralized, disaggregated, where you can introduce changes to each part of the experiment in a relatively hassle-free manner without impacting too much the changes on the overall experiment execution. So it could be sometimes confusing for the developers to actually copy samples from different experiments and go edit them to create their own experiment. So we created a simple script. It's a Python script that is going to help with the scaffolding of the experiment artifacts. So running it after filling up a simple attributes YAML file where you're going to place some basic experiment metadata is actually going to create the different experiment files inside a directory structure that is desired. So as you can see, the LitmusChaos Litmus repo has a strict directory structure wherein we are trying to group experiments according to their category, according to their nature inside of a particular folder called experiments. And each of them contains the actual YAMLs, the business logic YAMLs. So running this scaffolding script is actually going to create these artifacts. Some of them are going to be retained in the same repo where you're running them. That's the LitmusChaos/Litmus. And some of them are going to make it into the charts repo. So there is a README which you can follow to get started with the experiment. So I'll probably take you through that workflow just to see what is the content inside these generated YAMLs. So I'm inside the LitmusChaos/Litmus repo. This is my local workspace, and I'm going to go into the contribute and developer guide folder. I have an attributes sample, which is basically talking about creating a new chaos experiment for a Hello World app. This is a simple Hello World app that is basically going to return the Hello World string when you query the service endpoint of the deployment. So this is some sample data that we've created. So the experiment name is going to be Kill Hello Replicas. It has a version 0.1.0. It has a repository where the actual app is present. It's a simple Node.js app returning Hello World. There is a description. There is a support link for where you can contact the maintainer for the experiment. And then there are some keywords that you can reflect on the hub. So this is a simple file that you can sort of bootstrap, add information into, and then you can run the experiment. The experiment is scaffolded like this. You're going to have the Python. It's basically based on Python 3. We can actually simplify this by embedding this into a Docker image and just running the Docker file. I'm going to take an attribute sample YAML, and there are different generate type values supported. One is experiment, which will create all the artifacts, and the other is chart, which is only going to create the chart service version. So I'm going to use the experiment. My file name is different. So this has now created a folder called Hello World, which is indicative of the category or the app. And it's also going to create the experiment folder called Kill Hello Replicas, in which all the experiment artifacts are being placed. So let me go back and check whether it's created. So there is a Hello World folder. You can see the package YAML and the chart service version YAML. Package YAML is the one that links a given parent chart with all its experiments, and chart service version is basically talking about metadata of the parent chart itself. Let me just, okay, that's my copy command. So it's going to look something like this. So this is what we saw in the chaos charts repo as well, and this is what is going to be reflected on the hub. Now let me go into the experiment folder, kill hello replicas. So it's actually generated a set of YAML files, the Ansible logic YAML and the KTest job version YAML are probably going to continue to reside in this repo along with the prerequisites. The prerequisites is just an auxiliary YAML. It may be filled with actual data, something that you want to perform as a pre-check even before you run the experiment itself, mostly to do with, let's say you're taking too many variables or you probably make a decision about the chaos util that you want to select. All those kind of activities can be done in prerequisites. In our case, we really don't have much to be placed there. Most of our logic is being placed inside the Ansible logic YAML. So let me open that up and see what the bare bones skeletal structure of a playbook looks like. So this is the structure that you might have noticed in all the experiment playbooks. You're going to define vars that are being taken from the environment variables. And there is a tasks section, which includes blocks that are basically going to talk about generating the chaos result name based on the chaos engine if it has been defined, setting the chaos result CR, initializing it with status running. Then it talks about doing an application pre-check to see whether the app under test is available before doing chaos. It talks about doing invoking the chaos lib with some lib specific parameters, vars that are passed while you're calling the chaos lib. Then it talks about doing a post check after the chaos injection is complete. If things go well, the flag is set to pass, indicating that the application is resilient to the injected chaos. If any of these steps fail, then we set a flag called fail, saying the application is basically not resilient. And there is a step where you're going to update the result of the experiment back into you're going to patch the chaos result that you initially created with the running status to reflect the actual verdict of the experiment. So this structure is going to be standard to all the experiments that you're going to perform. The changes that you would be making are mostly going to be in this region. We're going to add a pre-chaos and post-chaos application liveness check that is very specific to your application. In case of Kafka, as you might have noticed, we have some liveness message streams which are being verified. It could be different for different applications. And this also could be different, the chaos util that you're selecting. In most cases, you would reuse existing chaos libraries, but you can create new libraries if the experiment demands that as well. So this is where you're mostly going to change and probably also add more variables here according to your experiment. So in my case, the exit check that I'm going to have for the Hello World app is to basically query the application, the deployment endpoint, and check whether I have the hello world string being received after I do the chaos. So chaos that I'm going to perform is to basically kill the hello world app. I'll just take you through the environment that I have. Before that, let me just copy over some existing templates that I have. So the modifications that I just mentioned to be made in the Ansible logic file, I've already kept it ready for this demo in the interest of time. So let me just get them over. And I also have the job YAML, which we'll use to test the experiment that we have just created. Okay, so let us look at the changes that you would have to make. The changes are very simple in this case. I've added some more variables. You can see that I've added the service IP and port for the application, Hello World application that we are going to use in our pre and post check to see whether the application is really giving me the Hello World page. And I've also added some more information because I've selected the chaos, the pod delete chaos, I'm adding the variables that are necessary for performing the pod delete chaos, such as the chaos duration, the chaos interval, and I've also initialized the chaos util variable to reflect the pod failure by Litmus. This is the util that I'm going to reuse, and etc. Whatever is necessary for performing the pod failure experiment, I've just added them. And as you can see, the rest of the steps are very similar. There is this additional step for post chaos where I'm just going to call the service endpoint of the hello world deployment and check if the hello world app, hello world string is being returned or no. And the experiment is going to fail if that is not returned, saying the application is not up. So this is pretty much how my Ansible logic file has been constructed or modified after the initial file was scaffolded. And there is a job file that I have modified as well. So this is going to help me test the experiment before I go on to construct my experiment CR and the chaos engine eventually. So this is the job spec, and I have to fill the this is what is the generated template, and I have to go ahead and fill the information that is defined by my instance. The app namespace, the label, the kind, the duration, etc. is going to be filled along with other values that you would like to give for the pod failure experiment. And once I've got the job, I'm going to run it and test it after I have generated an image. So as you can, as you might have already experienced, now that I have all my experiment artifacts, including the Ansible logic YAML mainly, I need to generate a test image, which is probably going to help me run this on a deployment setup. It could be Minikube or any other test cluster that you have in your on your laptop or in your lab, where you can test the job. So one of the ways to do that would be to just perform the Docker build step. We have the make file that you can just execute instead of running this command manually. I've already created a test image with the kill hello replicas experiment artifacts, and I have the job modified as well. So this is my GKE cluster where I'm running the hello world application. You can see that there are a couple of replicas of the hello world deployment, and I have a service which is basically having a node port as well if you'd like to see the hello world page. And there is a job that I've created by filling out the values. Whatever values were taken inside the Ansible logic YAML, I'm trying to pass it from the experiment job. And this is the data that will also add in the experiment CR eventually. I'm planning to do non-force delete, it's a graceful delete, and I plan to do a single replica deletion at a time and not the group delete. So you can see that the job spec has been modified to include some extra information to what was available initially, what was generated. Let me execute this job. Meanwhile, before we proceed with that, are there any questions about how the experiment was constructed?
Quick time check. Karthik, I think we're about to run out of our scheduled time, so if there are no questions, yeah, maybe we can wrap it up.
Cool. So I've just created the experiment job, and it's actually going to kill the hello world deployments. As you can see, it is already doing that. And eventually a chaos result is going to be created with the verdict. So the experiment is actually going to look for the hello world string by querying the service endpoint as it is running this chaos. And eventually the chaos result is going to be created with the verdict. And the same information needs to be added into the experiment CRs as well. And this CR is then going to be submitted into the chaos charts. Right now, the CI itself consists of very basic information without any of the additional vars, but you can just add them and submit the chaos chart, and that should be that. And yeah, do not forget to add documentation for the experiment that you just constructed. That's how you create the developer. That's basically a run through of the developer guide. So please feel free to ask more questions on the channel about better ways of scaffolding an experiment, or things that probably you feel should be considered while building the experiment, and we'll definitely look into that.
All right. Thank you, Karthik, for the detailed coverage of how you would build an experiment. Building and contributing more experiments is really the key. So with that, I think we are wrapping up the session. And as we discussed, from now on, it's going to be a monthly call. So the next community sync up is on the third Wednesday of January, which is going to be on 15th at the same time, 8:30 a.m. Pacific time. So till then, have a great time. Happy holidays, Happy New Year, Merry Christmas, and so forth. So with that, if there are any last questions we can take, otherwise, have a wonderful time till we meet again.
Yeah.
Thanks, everyone. Have fun.
Thanks, everyone.
Bye-bye. Thanks, Laura. Yeah, bye.
Thank you. Bye.
Yeah, bye.
Thank you.